Alright, and welcome to Absolute Value Transformations Level 2. Now, let's go ahead and start out with our absolute value formula, which is f of x is equal to a absolute value x minus h closed absolute value plus k. And as we look at this, in our very last video we talked about the letter a, which was either a vertical stretch or compression, or it reflected us across the x-axis. But in this one, in this problem, we're going to look at our k value. So k value will translate our graph up or down. It will translate our function up or down. Okay, so let's take a look here. We have our plus 5, and I know that it's our k value because it's on the outside. It's outside of the parentheses. Right, so this would be the inside, and over here we have the outside. Okay, so since we have our constant on the outside, it's being added, we know that this is actually going to translate 5 units up. Okay, first thing we want to do, let's go ahead and graph our parent function. We know it's at the origin, we know it's kind of just a normal width, and it opens up. Alright, now if I switch to g of x, where f of x plus 5, well, all I do is take my origin, I go up 1, 2, 3, 4, 5, and everything else about my graph is the exact same. So all we did was translate 5 units up. If we had subtracted by that number, we would have translated that many units down. Alright, let's move on to example number 2. I lied to y'all. This will actually be example number 3 from your homework, but let's go ahead and see what's going on here. Notice that right now this plus 2 is actually on the inside of our parentheses, and since it's on the inside, that must be our h value. Okay, so the first thing that we have to note is that we're always trying to make this grouping equal to 0. So if I were to say, hey, what value minus h equals 0, well, hopefully you would say h, because h minus h equals 0. Okay, so what we're essentially always trying to do is how can we make our grouping equal to 0? Well, when I look at this, I see x plus 2, which I can set equal to 0, and to solve for x, I simply subtract 2 from both sides, and so x must be negative 2, or aka h is equal to negative 2. And this will translate our function 2 units left. 2 units left. Okay, so our parent function must look something like this. You're going to draw that every single time. And our function g of x, because our x value is actually a negative 2, will translate 2 units to the left, and it'll have the same width, the same height, and everything else will look the exact same. Now, one thing that I just should have mentioned a little bit better is that our h value will actually translate us left or right, depending on if h is positive or negative. Okay, let's go ahead and move on to our third and final example, where we're going to combine both examples 1 and example 2. Okay, so let's put all this together. If I were to give you the vertex form, f of x is equal to a absolute value x minus h plus k, well, we know that our h value will translate left or right, and our k value will translate us up or down. Okay, so let's take a look right here. We're going to say, you know what is my x value? Well, when x plus 1 is set equal to 0, I subtract 1 from both sides, and x is equal to negative 1, or aka h is equal to negative 1. And then I know that my k value is equal to negative 3. It's just exactly what we see. So let's go ahead and graph our parent function. We're just here at the origin. We draw our V shape. But let's go to our blue value, and we'll say, okay, we shifted to the left 1, and down 3, so we can go to the left 1, down 1, 2, 3, and our graph will hold the same shape in terms of width. Alright, I hope these 3 examples help, and I'll see you guys in our level 3 video.